So all of you did this circuit? So what we are trying now is, see earlier we tried the transient response, right? That means you have LCR circuit, you give a sudden step and see what happens. Now you are giving a sinusoid and see how the, first you see the RC circuit, how it behaves. So you see we are giving on the one end of the capacitor that black trace, right? That is our sine wave input. And you can see we are measuring the voltage across the resistor. And voltage across the capacitor is actually A1 minus A2. So all the three are plotted. So three graphs you should see like this. And what is that phase difference? Why you are putting 2 micro? What is it? Why it is 29? Huh? Oh, okay. So 47-degree phase shift. What is that phase shift? See, if you give AC to one capacitor and the other side when it comes, do you expect some change? What is the kind of change you expect? Yes. See, it is something like this. You have a sine wave here and a capacitor, then a resistor. So what we are trying to measure is here A1 and A2. So what we see is across the capacitor, voltage signals are shifted. Phase is shifted by 47 degree. And that is given in the textbook. If you see theory, theta is equal to tan inverse Zg by R. Zg is 1 by 2 pi Fc. Okay, but there is a calculator. You don't have to do this equation. In the corner there is a calculator. So enter 150, 100 and then 1 you have press calculate. It is supposed to be 46.7 and we are getting 47. What are the values you are getting? Find out that. Okay, try that quickly. Now notice one thing. Somewhere in the textbook it is there. Across the capacitor there will be a 90-degree phase shift. What is that? What is that 90-degree phase shift across the capacitor? Have you heard about that? What is that? The textbook says the current leads by 90 degree, right? Can you see it there in this picture? Anywhere current leading by 90 degree? Is it visible here? See, look at the blue trace. What is it? VR, right? Voltage across the resistor. And you know across a resistor, voltage and current are in phase. So that means blue is the phase of the current in the circuit. And what is red? Red is voltage across the capacitor. So you can easily see from here, when the voltage across the capacitor, the voltage is at 0, current is already up by at the peak 90 degree, right? So from this picture itself you can see that current is leading. Now there is 1 micro, this value, and you also notice here these values. Suppose you have two things in series. You have the capacitor and resistor in series, and voltage total is 3, across capacitor is 2.2 and across resistor is 2. Why it is so? 2 plus 2 is supposed to be, but what you see here is 3. Is there anything wrong? See here, Voltage across the capacitor 2.22, voltage across the resistor is 2.03 and total voltage is 3. Is that alright? Yes or no you have to say, right? Is there anything wrong? You have to add it because they are not in phase, right? How do you add it? That 2 point, just to find out how much is the 2.2 square plus whatever here square 2.03 square root square, yeah, square, total square root you have to take. Right? 3 volt. So there is nothing wrong. It's like that. But now suppose if I pull out that capacitor and put a resistor in that place, what do I get? There is no phase difference, right? Both are resistors. Now I remove the capacitor and put that 10 millihenry inductor. $10 millihenry inductor, okay? Now find out what is the phase shift. Very small, right? Increase the frequency. The 150 is too low. Make it say 1500 or something. Then you get, so for 1500 now you can calculate how much is 10 millihenry will give how much. 3000 you have given. 10 and C is 0. Calculate. Minus 10.7, 11.3 is actually resistance is not 1000, it is 1020 because the 20 ohm for the inductor. So you have 11.3 and 10.5. Error is more. Okay, all of you got this? Now I am going to for the third stage. If you are not catching up, you can do it assuredly. So I am going to now change, put the capacitor back. So now we have so all these fellows are going to be present now. Capacitor is there, then comes inductor, and now that junction of that capacitor and inductor, no, I will move it. That I'll give it to A3. Anyway, picture is there, you can see the schematic, whatever. Yeah, now do one thing in the calculator, you give both 1 micro and 10, and it says something like 1500, so give a 1600 here. The resonant frequency it is calculating. So 1600 phase difference is 0.3, so adjust it, make it 0. Slightly tweak it, so make it 0. Okay, so now phase difference is 0, right? That means you have 1 micro and 10 millihenry in series, and across these two elements together we have 0 phase shift. That means it is resonance point. So now you can see that red is the voltage across the LC. It is not exactly 0, slight waviness is there because of the 20 ohm resistance. But how about the voltage across the inductor and across the capacitor? Just show that also. Show V and L. Yeah. See, this is how you get the resonance. If you look at it, that red is the trace, the total voltage across L and C together, and at the same time across C and across L, the voltages are not zero, but they are equal and opposite phase, so that net result is zero. So this is how you can see how the series resonance works. So you can try this for other LC values, you calculate and go there, get the phase, and so all of you should try doing all these three. Huh? That we did.